Hey everybody, today we'll do another video and today we will do what is called a Pascal triangle, right? And we will use the Pascal triangle to learn more about the binomial expansion. That's it. That's the whole purpose of that we will be using the Pascal triangle, right? And eventually we might do a C++ program that outputs the Pascal triangle. But at the moment, in this video, we will just focus on how to create a Pascal triangle, right? Okay, so Pascal triangle is something like this. So Pascal triangle is something like this, right? So something that start with one at top, right? One, right? And then from this, it will form a triangle looking shape, right? With ones at the edge, right? So it will look like this, right? So that will be one, right? And this will be another one and another one, right? But remember, this has got to be this is not easy to do it in this software, let me tell you. And the reason being is because it's kind of hard to keep this stuff in line, right? But okay, we will try the best. So here we do one, and then over here, right? So I look at this, right? Start with the three, right? Three, right? Like forming a triangle, first triangle, right? Assuming that you form a triangle like this, right? You do from one to one to one, right? Three ones, right? Now, what you do is you add these two, right? And you start with another one, right? Like I said, it has at each edge of this triangle will have ones. So we start with another one, right? Here. And then we add these two, right? 1 plus 2 is, 1 plus 1 is going to be equal to 2, right? And you add another one, right? Then, okay, so that is row 0, row 1, and row 2, right? And I will explain why we do that eventually, right? But then we look at this, and we look at this, and we look at this on the side, right? Right? So we look at the two in the middle, and then now you have another number here. You have a two in the middle. We have a ones, and I have a two. I have a one, and I have a two, right? So what I do right here, I add another one, right? Add this two, I get 3. And then I add this with this, it's going to be what? This is going to be another 3. And this is going to be 1. Right? Next, we start with 1 again, right? Start with 1 again, right? So then we add start with 1 again, right? We add the numbers, these numbers above. It's going to be what? It's going to be 4. And then I add these numbers on board. It's going to be 4. And then, of course, it's going to be 1. Right? Now, do next, right? So it's going to be 1. It's going to be 5. And then it's going to be another 5. The middle, and then 1. Right? As you can see, it doesn't look like a perfect triangle, but you can actually get an idea. That looked like a little triangle right there, right? In this case, because it's not easy to work with this software, but just erase this part. I think I did another video with this in Spanish and I didn't erase it, but anyway. We can erase that. Okay, so we keep going, right? We could maybe do one more line would be enough, I think. Right? One more row, I'm sorry. So now we can add another row here. So another row. And so we add another row. And then we do another one, right? And then I add this, it's going to be 5, right? I'm sorry, 6. So it's going to be 6. So I am adding this. And I'm trying not to make this like this, but for some reason I can make it. If I can make it. If I can make it, right? So I can make it 1, right? Right, so now we add in this, right? And then we get 6. And then we got another 6, right? Add in this and this, we get another 6. And then we get 1. Right, now we can add one more. We can do 1, right? And then it's going to be 7. And it's going to be this plus this, going to be another 7. And it's going to be a 1. But you get an idea. You get an idea that it looked like a little triangle. Yeah. So it looked like new triangle, right? So that's the whole purpose of it, right? Now let's do a little bit of let's do a little bit of okay. Let's do a little bit of the mathematical, well, the binomial expansion, right? Okay, so let's say that bio mean 2. I think you guys agree with me. Bio mean 2, which means 2 terms add together, right? But if I want to spend it, right, expansion, if I want to spend that, then that means that I have to multiply by maybe raised to a certain power, correct? So let's say that you want to do A plus B to the nth power, right? Okay, so, and then let's say that you want to do n is equal to 1, n 2, n is equal to 3, n equal to 4, right? Okay, but so if that is the case, are we missing something here? So we're missing one thing, right? I can do it, no problem. It makes sense, right? But what if I want to start at 0? See, like math, the power of 0 represent that number to the 0 power, right? Which is equal to 1, right? And I will explain that. But, okay, let's say that we start from 0. 0, 1, 2, and 3, right? So we start from 0 and up to 3, right? Okay, so let's do something, right? So let's do 0, the power 0 first, right? Or any number to the 0 power, I'm sorry. So a plus b to the 0 power is going to be equal to nothing but 1. Why? Because it doesn't matter what this number is. Any number to the 0 power is equal to 1, right? Now, if I do a plus b to the 1's power, to the first power, is going to be equal to nothing but that number. Any number to the power of 1 is equal to that number, which is going to be a plus b. Next, we do a plus b squared, right? This is going to be a little different. We have to do a little more work to do this, right? So then we do a plus b times a plus b, right? And then we do that, we say that a plus a, and then we multiply this across, right? So we get that a plus b quantity squared, right, is equal to a times a is a squared. A times v is equal to plus a v. B times a is equal to plus a b, and b squared, I'm sorry, b times b is equal to b squared, right? Now, we need to combine like terms, right? And this 2 in the middle, this and this can be added together, and I get that a plus b squared all right, so a plus b squared is equal to a squared, which is this one, plus these two terms is going to be equal to plus 2ab plus b squared, correct? Now, oops, okay, so what I can do right here is the following. So now what I can do is that I can actually do the next one, which is going to be, a plus b to the 3rd power, which is equal to, right here, as you know, that a squared is equal to this, right? A squared is equal to this, correct? Now, isn't a cubed, is it not equal to a? I'm sorry, a plus b cubed, is it not equal to a plus b? A plus b, right? If you want to just, deal with the whole thing, right? A plus b times a plus b times a plus b. That's what it is, right? But we know that these two terms is this, and this is equal to that, right? This is equal to this. So what I can do is substitute this this right here by this, right? And keep one of this, right? So I can do the math with. Okay, so in this case, I'm going to say that a plus b cubed is equal to a plus b to the 1 power, right? To the 1's power, right? That's going to be to the 1's power times a squared plus 2av, right? Plus 2av, right? Plus b squared, right? Now, doing this, I get what? I get a plus b cubed is equal to a times a squared is equal to a cubed. A times this 2av is equal to plus 2a squared v, right? Then this times this is equal to a times b squared is equal to plus a v squared, correct? So this is equal to, right? So so that is A, right? Now I gotta do B, right? And then I do B, right? Because I just multiplied A across. Now I gotta do this B right here, right? So this is going to be equal to what? This is nothing but B times A squared is equal to, actually I should put, right? So I should put a squared b, right? This times this. Then I'm doing this times this, right? So it's going to be plus 2ab squared, right? So I have a b right here, right? And I have a b right here, right? That's why I'm getting the square, right? Because like this is the b, multiplying that 2av, and a stays the same because a is the power of 1, right? So b is also the power of 1, but because I have added the exponents, I get b squared, right? And then the next one is going to be b squared times b, b squared, or you can say b times b squared is going to be equal to b cubed, right? Now we add this, right? I know that I don't have an a cubed and I don't have a b cubed, right? But what I can do, I can say that a plus b cubed is equal to a cubed plus this and this, right? So it's equal to 3a squared v plus this. I got a b squared right here, and I got another b squared right there, and I got 3ab squared, and then I just bring that b cubed down, and I got b cubed, right? So that is the whole expansion for the power of 3. Now think about if I had a bunch of power, it's going to be making very messy to get all the, the coefficients, right? Now, I will go up to here and I'm going to go through a lot of more because it's going to take forever to do this. But okay, so that is that, right? Now let's compare this coefficient, right? So I got a coefficient that's 1, right? And this is 3, and this is 3, and this is 1, right? So any number to the q power, right, is that number. In this case, is 1. The second number that we see right here is 3, and this also 3, and then the number to the right, which is going to be the last one on the other side of the triangle, is also 1, right? So now let's compare those numbers with the triangle. Okay, so we have, remember we done, okay, so, and okay, let me just do something right here that I did not do. Let's name this, let's do this, row 0, row 1, row 2, row 'All right, so we do row 3, row 4, row 5. All right, so you can see, and I will explain why I'm doing this real quick. Because okay, so this is okay. So why is not okay? Let's see. Okay, so this is row 6 and row 7, right? Okay, so remember that we did to the power of n, right? So this row represents the power of n, basically, right? So we did that to the n equal to 3, correct? Third power, right? So let's do a little quick review here. So, right. So in the first one, we know that was 1, right? Any number to the 0 power was equal to 1. The first one, right? Any number to the any number to the 1 power. Remember, it was that number, right? It was that number, which is a plus b, correct? Next, we did a, and then we did r. N is equal to 2. Then we did a squared, right? A plus b squared, right? We did at n is equal to 2. We did this one, right? Now at n equal to 3, right? At n equal to 3, we are in this row, right? This is when we have a squared. We have 3. This is a cubed. right? Because we did this, right? Now this is a cube. This is the 3 that we have, right? 3 b 3a squared b, and then this is the 3a b squared, and of course this is the other b squared that we have. So these are the coefficients. You see that? You see that, right? And I hope it makes sense, right? Because this is what we got right here. So this is the first one, this is the second one, right? This is row 0, right? This is row 1, row 2, right? You can see it right there. And you can have, and then row 3, which is this one right here, right? And the stuff is getting messier and messier, right? So that's why we use the Pascale triangle to get the coefficients of the binomial expansion, right? That's the whole purpose of it, right? Thank you for watching, guys. I hope this video helps anybody who is doing this type of mathematics. If you like this video, please subscribe and share this video. And also remember that if we learn anything right here every day, right, it's because of the grace of Jesus. Is awesome, right? He's awesome with us, right? Thank you for watching, and I see you in the next video. Thank you for watching.